Alright, this is the third tutorial of 3. In this case, we're going to be looking at rainfall data that comes from measures around Snoqualmie Pass and the area around there. The reason that this is interesting is we're looking at rainfall amounts over time, and so you would expect that there are perhaps underlying distributions that make up this overall distribution. Perhaps there's seasonality distributions and otherwise. So we'll be looking at that data here. I won't necessarily rehash a lot of the commands you've already seen in the first tutorials, other than saying we're importing the same libraries here. So make sure that you have those executed. The CSV file is titled snoc, which is of course a great choice for naming files, but it's snoq.csv, and we're going to use the sc.txt file to read in the file path to create a rainfall data RDD. If you look at this rainfall data RDD, again to just verify that you have the right numbers in there, that's what you should see for the first 5. And if you've been listening to the first 2 tutorials, you should be relatively unsurprised that our first step is going to be making sure that this data is in the right format for putting it into the Gaussian mixture model function. So we're going to say lambda line float x, and again a key point here is we're going to split based on a comma, and the reason that we do that here with the comma is that we have a CSV file. So if we look at formatted rainfall data, we should see things and we should know that these are in floating point values now. So in contrast to what we did in the first 2 examples, we're going to create 2 models here. The first model is going to contain 2 underlying distributions, so nothing much changes from our examples that we've done before. We call it formatted rainfall data. In this case, we're going to say 2. And in the second model we train, very creatively named, we're going to call it 3. So in this case, what we're doing is we're varying the number of underlying distributions that we hypothesize are in the data. So if we execute this, we have now created these 2 objects that, and it will take a little while to do due to the size of the data here. So again, we can go through the process of printing out these parameters, and in this case we can say our weight. Again, if you've been getting the hang of this, we should be calling this on our rainfall GMM model, which comes from the 2 underlying distributions, and we should be calling the weights object here. We can also, again, we want to get the measures of center for these distributions, so we're going to take GMM model rainfall 2, and we're going to say, okay, give us back the distributions. In this case, we're taking the Gaussian distribution and we're returning the mean measure. For the last one, again, having a measure of variance is very important here. So we're taking GMM model rainfall, and again, it's rainfall 2. We're calling the Gaussian's object on it again, and in this case, we are calling, so we've selected our sigma value, and to print it effectively, we want a 2 array. So if we look at this, we have a weight, mu, and we have sigma. Now, note that in comparison to the previous tutorials, it appears that we have a relatively simple distribution. Well, the reason is that we only have measures of rainfall. We don't have more than one feature in the data. What you were seeing previously in the other data sets is they had two features present, and so the vectors that were being returned were higher dimensional than our example here. So we can, with just a couple of adjustments, look at what happens for the 3 distribution model. If we run this, we can see that in this case, obviously they're going to return different values. The question becomes, how do we go back and compare this in the original data, right? We don't have labels. And so in this case, for mixture modeling in particular, it really requires going back to experts in a particular area to understand, okay, is it useful if we found that there were 3 underlying distributions? It's very likely that this 2 or 3 distribution model is touching on different aspects of seasonality for the amount of rainfall. Thank you for listening to the 3 tutorials.